friends, welcome to our YouTube channel Nagaraju Academy. The main aim of this lecture is to discuss about the electrical solutions of the ESE 2021 in a very detailed manner. And if you like the content of our channel, then please do like, share and subscribe our YouTube channel, and don't forget to press the bell icon button. So whenever we upload a new video, the direct notifications comes to mobile. If any improvements needed in our lectures, then please do comment in the comment section. We will definitely include all those improvements in the coming lectures. So why to waste more time? So let's get started. So now we are going to solve the 31st question. See the question here. How many seconds would a clock lose per day if the length of its pendulum was increased in the ratio of 900:901? So in this question they are asking, if the length of the pendulum is increased in the ratio 900:901, then how much is the clock is going to lose the time in a day? So in how many seconds it is going to lose in one day, the clock. So what are the four options? Option A, 48 seconds is a correct solution of this question. So let's solve this numerical. So in this question they are given that here the ratio of the lengths of the pendulum is L1/L2 is equal to 900/901. So if the length of the pendulum is increased, then what is going to happen in the clock time period? We need to figure out how much seconds it is going to lose in a one day. We need to figure out. Suppose these are the two pendulums of length L1 and L2. So I am going to assume L1 is equal to 900, whether it can be centimeter or anything. So therefore if L1 is equal to 900, so therefore L2 will be 901. Suppose this is the length L1 of the pendulum and this is the L2 of the pendulum. So you know the basic formula, which is time period of any pendulum, which is T is equal to 2 pi under root over L by G, where L is the length of the pendulum and G is the gravity, acceleration due to gravity. So therefore here these 2 pi and G are constant, so therefore time is directly proportional to under root over length. So therefore T1 by T2 is equal to under root over L1 by L2. So I want to know what is the value of T2. So therefore T2 is equal to under root over L2 by L1 into T1. So therefore here I know the value of L2 and also I know the value of the L1. So I am going to substitute those values. So finally T2 is equal to under root over 901 by 900 into T1. So if you solve this ratio, we are going to get finally T2 is equal to 1.00055401 T1. So see here, suppose what I am going to do is, for this first pendulum, I am going to make it a swing, a one swing. I am going to make it a complete one swing. So I am going to assume the time for this one swing is 24 hours. So I am going to assume for one swing of this pendulum from here to here, this one swing is totally 24 hours. So let T1 is equal to 24 hours. Then I want to know for this same pendulum, this another pendulum of length L2, how much time it is going to take for one swing from here to here. So if this first pendulum of length L1, if it is making a one swing in 24 hours, then I want to know for this one swing, how much time this second pendulum is going to make. I want to figure out. So therefore here in place of T1 substitute 24, then finally in place of T1 I substitute 24 hours, then finally this is the value which I am going to get here, which is 24 point this value into hour. So here for one swing, for the first pendulum, in order to make a one complete swing, it is going to take 24 hours. But for the second pendulum, in order to make one swing, it is going to make some more than 24 hours, means a more than small amount of 24 hours it is going to take. So I want to know what is the subtraction of this T2 minus T1. So therefore if you take T2 minus T1, this is the value I am going to make. So therefore this much amount of extra time is going to taken by the pendulum L2 in order to make a one complete swing. So therefore I want to convert this in terms of seconds. How many? This much hour, how much in seconds I want to figure out. So 1 hour is nothing but 3600 seconds. So I want to know how much second for this one. So this hour, how much seconds I need to figure out. So if you take the ratio 1 by this value is equal to 3600 by x, and if you solve this one, I am going to get x is equal to 47.9866. So if you round it to one digit, finally I am going to get here x is nearly equal to 48 seconds. So therefore here this T2 is going to take an extra, it is going to take an extra time of 48 seconds. So therefore this is a very fast and this is a very slow. So therefore it is going to swing in a faster time when compared to the second one. So therefore here, suppose if the time period is 24 hours, means it is going to lag by 48 seconds. So therefore here this is the correct solution of this question. So now we are going to solve the 32nd question. This is the question here. What is the total average power in the unit amplitude square wave of period t and 50% duty cycle? So in this question they are given a unit square value of time period t with a 50% duty cycle. So then we have to find what is the average power for this signal. We need to figure out. So what are the four options? Option C 0.5 watt is the correct solution of this question. So let's solve this numerical. So in this question they are given a periodic signal of square wave of unit amplitude, and also in the question they are given the duty ratio which is T on by T, which is 50% means 50 by 100, which is 1 by 2. So therefore T on is equal to T by 2. So therefore this is the T on, which is T by 2. So therefore for half of the period the value is 1 and remaining half period its value is 0. So it is basically a periodic signal. So for a periodic signal we have to find what is the average power we need to figure out. So basically all periodic signals are power signals. So therefore I want to know what is the power, average power, which is the total energy by total time period. So you can take any number of cycles. So I am going to take only the first cycle, means from here the only first cycle I am going to consider. So therefore here the energy is equal to integration 0 to total time period x of t whole square dt per time period of the first cycle signal, which is t. So therefore the signal is going to have only the unit amplitude from 0 to t by 2 and remaining thing it is 0. So therefore integration you have to do only from 0 to t by 2. So 0 to t by 2 1 square dt by capital time period, which is t. So if you do the integration we are going to get 1 into t by 2 by t. So t get cancels. So therefore the average power is 1 by 2. So therefore the average power is equal to 0.5 watt. So therefore for this periodic signal the power is equal to 0.5, whereas the energy is equal to always infinite for a power signal or for a periodic signal. So therefore this signal is said to be a power signal because power is a finite value. So all periodic signals are power signals. So now we are going to solve the 33rd question. So the question here, in the figure if C of S is the Laplace transform of the output and R of S is the Laplace transform of the input, the equivalent transfer function T of S is. So for this block diagram they are given a output is C of S and the input is R of S, and then we have to find what is the overall transfer function of this system we need to figure out. So what are the four options? Option A is the correct solution of this question. So we are going to solve this question by using the Mason's gain formula. So therefore here let's solve this numerical. So this is the block diagram which is given in the question. So we have to find what is the overall transfer function we need to figure out. So by using the Mason's gain formula we are going to solve this numerical. So first I want to know how many forward paths are going to present, means from input to output how many forward paths are going to present. So we have to go in the direction of the arrows. So therefore here this is a one forward path, and also the another forward is this is the path. So therefore there are basically two forward paths. So I want to know what is the forward path for each and every gain. So therefore here the gain is S into 1 by S. This is the first forward path gain. So S into 1 by S, which is S. And also second forward path gain I need to figure out. So therefore 1 by S into 1 by S. So therefore 1 by S square. And I want to know how many loops are going to present in this block diagram. So therefore here if you see carefully here this is a one loop. So therefore we are going to make a one closed loop. So therefore this is a one loop. The gain is S into and here there is a minus 1. So therefore S into minus 1, which is S into minus 1, which is minus S square. And similarly there is also another loop which is this is a way. So by this way also we are going to make one loop. So therefore the gain is 1 by S, here the gain is 1 by S, and here the gain is minus 1. So therefore 1 by S into minus 1. 1 by S into minus 1, which is minus 1 by S. And similarly the third loop is, this is the third loop we are going to make. So this is the third loop. So I want to know what is the gain of this third loop. So therefore you have to multiply each and everything, which is S into 1 by S into and there is a minus 1. So therefore S into 1 by S into minus 1. So we are going to get minus S square. And there is also the last closed loop, which is the fourth loop, which is this is the way. So this is also another loop we are going to make. So basically there are 4 loops. So I want to know what is the loop gain of this fourth loop, which is here 1 by S and here 1 by S and here it is S, and also there is minus 1. So therefore 1 by S into 1 by S into S into minus 1, I am going to get minus 1 by S. So all these 4 loops are going to touch each and every forward path. So therefore this delta 1 is equal to 1 and delta 2 is equal to 1, and there are no non-touching loops, all are touching to each other. So therefore delta is equal to 1 minus of L1 plus L2 plus L3 plus L4, because you can't write more than this because there are no non-touching loops. So by using the Mason's gain formula, C of S by R of S is equal to P1 delta 1 plus P2 delta 2 by delta. So substitute each and everything. P1 is S into 1 plus 1 by S square into 1 by, so delta value you have to substitute 1 minus of all these loop gains value you have to substitute in this formula. And if the simplification, we are going to get S plus 1 by S square by 1 plus 2S square plus 2 by S. And if we do the further simplification, so finally this is the value we are going to get, which is C of S by R of S is equal to S cube plus 1 by 2S to the power of 4 plus S square plus 2S. This is the correct solution of this question. So by using the Mason's gain formula, we have simplified this question. So now we are going to solve the 34th question. See the question here. What is the temperature coefficient of the resistance of material used in a resistor if the resistance at 25 degrees centigrade is 50 ohm and at 70 degrees centigrade is 57.2 ohm? So based on these two parameters, means at temperature of 25 degrees the resistance is 50 ohm and at 70 degrees centigrade the resistance is 57.2. So based on these two things, we have to find what is the temperature coefficient of this resistor we need to figure out. So what are the four options? Option D is the correct solution of this question. So let's solve this numerical. So in this question they are given that at 25 degrees centigrade the resistance is 50 ohm and also at 70 degrees centigrade the resistance is 57.2 ohm. So we have to find what is the temperature coefficient of this resistor we need to figure out. So basically, so based on this we can plot a diagram, which is at 25 degree temperature the resistance is 50 ohm and at 70 degree temperature the resistance is 57.2 ohm. So it's a diagram between the resistance and the temperature. So as the temperature is going to increase, the resistance is also increased for a conductor. So basically a conductor is a positive temperature coefficient resistance, means as the temperature increases the resistance is also going to increase. But whereas for semiconductor and insulator, these are the negative temperature coefficient materials, means as the resistance increases, as the temperature increases, the resistance also decreases. So therefore these two are the negative temperature coefficient materials, whereas a conductor is a positive temperature coefficient material. So based on this is a basic formula, which is resistance at any temperature is equal to the resistance at the 0 degree into 1 plus alpha T. T at this particular temperature we have to know what is the resistance R. So based on this, for the first equation, which is 50 ohm is equal to R naught into 1 plus N in place of temperature 25. So 25 into alpha, this is the first equation. And similarly for the second equation, which is the resistance is 57.2 is equal to initial temperature, means at 0 degree the resistance is R naught. So R naught into 1 plus here alpha into T is a 70 degree. So 70 degree. So we need to find what is the value of alpha. So we can divide 1 by 2. So therefore this R naught going to get cancels. So therefore there is only one equation with only one unknown. So after solving this one, we are going to get the temperature coefficient of this resistor of this conductor, which is 1 by 287.5 is the correct solution of this question. So we are going to solve the 35th question. See the question here. In a ferromatic material, the losses due to the hysteresis are. So we have to find what this question they are asking. The hysteresis loss in a ferromatic material, what is the relation with respect to the frequency in this question they are asking. So what are the four options? Option A, directly proportional to the supply frequency, is the correct solution of this question. So let's discuss something more about this one. Basically this is a ferromatic material. So in this ferromatic material, if you are going to supply any external magnetic field, the dipoles which are present in the ferromatic material are going to align in the same direction as the magnetic field which are going to produce. So therefore, if you are going to change this magnetic field direction, then these dipoles are also going to change their direction. So because of this, some amount of energy is going to consumed by these dipoles. So it is going to have some amount of losses. So as these dipoles are going to some amount of energy, this loss is called as a hysteresis loss. So this is called as a hysteresis loss. The expression of the hysteresis loss is eta into Bm to the power of 1.6 F into volume. So basically this hysteresis loss is directly proportional to the supply frequency. So pH is called as the hysteresis loss, where eta is called as the hysteresis coefficient and Bm is called as the maximum flux density, and this is a 1.6 is the Stefan's coefficient. So therefore F is the supply frequency and volume is nothing but what is the volume of this ferromagnetic material which you are going to use for this when you are going to supply this magnetic field. So in this question they are asking only what is the relation between the hysteresis loss and the supply frequency. So blindly we can say these are directly proportional. So now we are going to solve the 36th question. See the question here. An heater element is made of Necron wire having resistivity equal to 100 into 10 to the power of -8 ohm meter. The diameter of the wire is 0.4 millimeter. So the length of the wire required to get a resistance of 40 ohm and 1000 watt is. So in this question they also given the resistivity, and also they are given the diameter of the wire, and also they are given the resistance of this wire also they are given. So based on this data we need to find what is the length of the wire. We need to figure out. The wire is basically a Necron wire. So what are the four options? Option A, 5 meters is the correct solution of this question. So let's solve this numerical. In the question they are given the resistivity of the material is 100 to 10 to the power of minus 8 ohm meter, and the diameter of the wire which is 0.4 millimeter. So the radius is the half of the diameter. So if you do this one, we are going to get 0.2 millimeter. So based on this we can calculate what is the area of the wire, which is pi r square. And similarly we have to find what is the length of the wire, and also they are given that the resistance of this wire is 40 ohm. So the basic relation is resistance is equal to rho L by A. So blindly substitute all those values. The resistance is 40 ohm and the resistivity which is 100 to the power of minus 8, and L we need to figure out. Area is pi r square. So pi area is 0.2 means the radius is 0.2 millimeter, means we are going to substitute, we need to transfer in terms of meters, which is 0.2 into 10 to the power of minus 3 meters. So therefore substitute here and do the square, then we are going to get finally L is equal to 5.024 meters, but we are going to approximate, so therefore L is equal to 5 meters is the correct solution of this question. So the value of pi we are going to assume it as 3.14. So the value of pi is 3.14. So now we are going to solve the 37th question. See the question here. Nichrome is an alloy of. So basically in this question they are asking what is the nichrome consist of? What are the components it is going to consist? So option C is the correct solution of this question. So let's discuss something more about this one. So now we'll discuss something about the Necron wire. So Necron wire is basically consist of the manganese from 1.5% and nickel around 75 to 78%, and also the chromium from 20 to 23%, and the remaining percentages of the iron. So this is all about the combination of the nichrome. So basically nichrome has a highest melting point which is 400 degrees centigrade. So because of highest melting point it is not used in a fused wire. So therefore because this nichrome has a highest melting point, so because of this reason the fused wire is not made of nichrome. So basically the fused wire is made up of alloy of lead and tin, because for the characteristic of a fused wire must be it must have high resistance and the melting point should be very low. So therefore the alloy of lead and tin has a very low melting point around 200 degrees centigrade. So because of this reason only the fused wire is made of alloy of lead and tin. So because it has a melting point of low, but here the nichrome has a very high melting point. So because of that reason only this nichrome wire is never used in fused wire, but it is used in toasters and also in heaters. So if you see any toasters and heaters, in this nichrome wire is going to use. So basically its color is silvery gray color, and it highly corrosive resistance, means it is highly resistive to corrosion also. So these are some of the important properties of the nichrome wire. So therefore these are the components which are going to present in the nichrome wire. So you have to remember all these components, even the percentage value also you have to remember. So more amount of percentages of the nickel. So nickel is going to have nearly 80% contribution to the nichrome. So now we are going to solve the 38th question. See the question here. A multi-stage amplifier employs 4 stages, each of which has a voltage gain of 40. The overall gain of the amplifier is approximately. So basically there are 4 stages, of each is having a gain of 40. So we have to find what is the overall gain in terms of dB value we need to figure out. So what are the 4 options? Option D, 128 dB is the correct solution of this question. So let's solve this numerical. So it is basically multi-stage amplifier, means it is going to consist of different blocks. So each block has a voltage gain of 40. So we have to find what is the overall voltage gain in terms of dB. So here we are going to assume there is no loading effect. So because in the question they are not given whether there is a loading effect is present or not. So basically if they are not given anything regarding loading effect is present or not, then by default we are going to assume there is no loading effect. So therefore the overall voltage gain will be multiplication of the each and individual voltage gain. So each value is a 40, so therefore 40 to the power of 4. So we have to convert in terms of dB. So dB, if you want to know 20 log base 10, you have to take the numerical value. So 20 log base 10 here, 40 to the power of 4. So 4 comes here, it will become 80 log 40 base 10. So 40 I am going to convert into 4 into 10. So by using log m into n is equal to log m plus log n. So therefore 80 log log 4 base 10 plus log 10 base 10. So 4 I can write in terms of 2 square. So therefore 4 I can write in terms of 2 square. So therefore this 2 is going to come to this side. So therefore 80 into 2 log 2 base 10 plus log 10 is nothing but log 10 base 10 is nothing but 1. So therefore you have to know what is the value of the log 2 base 10. So log 2 base 10 value is 0.301. You have to remember this value because calculator is not allowed in the ESE examination. So log 2 base 10 is 0.301. So if you substitute here, finally we are going to get 128 dB is the correct solution of this question. So in the question, if they ask if they want to convert in terms of dB, so you always take 20 log base 10, that numerical value you have to keep it here. So remaining everything is a simplification. So now we are going to solve the 39th question. See the question here. A moving coil measure of 50 ohm resistance reads up to 25 milliampere. So what is the value of the series resistance so that it can read up to 10 volt? We need to figure out. So basically, out of the 4 options, option C, 350 ohm is the correct solution of this question. So let's solve this numerical. So in this question they are given that the major resistance is 50 ohm and maximum current it can read by this meter is which is 25 milliampere. So now we have to keep an extra series resistance, so therefore this whole measurement, this whole instrument can measure up to 10 volt. We need to figure out. So what is this value we need to figure out? So basically, so if you see carefully, by using the voltage rule, means by using the V is equal to IR principle, the overall voltage is equal to 10 and the current is going to flow between the RM and RSC. So these two are connected in series fashion. So total voltage is equal to current into RM plus RSC. So total voltage is 10 volt and the current is 25 10 to the power of minus 3 and RM is 50. So we have to find what is the RSC. So only one equation with only one unknown. So I am going to take this one to the denominator. So 10 into 10 cube by 25 is equal to 50 plus RSC. So 10,000 by 25 it is nothing but 400. So to 400. So therefore RSC is equal to 400 minus 50. So we are going to get RSC is equal to 350 ohm. So this is the one way. And we also can solve this numerical in another way by using the direct formula, which is RSC is equal to RM into M minus 1, where M is the total voltage by voltage which is measured by this M. So therefore Vm is nothing but this is the voltage Vm. So Vm is equal to Im into Rm. So Im is 25 into 10 to the power of minus 3 and Rm is 50. So if you solve this one, we are going to get M is equal to 8. So therefore RSC is equal to Rm is 50. In place of M, substitute the value of M, which is 8 minus 1. So 50 into 7 is nothing but 350 ohm. So you can do it in either way. So in both ways the answer is same, which is 350 ohm is the correct solution of this question. This is the last question of this lecture. An 8-pole DC shunt generator with 778 wave-connected armature connectors and running at 500 RPM supplies a load of 12.5 ohm resistance at terminal voltage of 250 volt. The armature resistance is 0.24 ohm and the field resistance is 250 ohm. The magnitude of the armature current is. So based on this data, this is a lap winded machine of DC machine. So therefore DC generator machine. So we have to find what is the magnitude of the armature current. So we have to find what is the value of the IA. We have to figure out. So what are the 4 options? Option C, 21 ampere is the correct solution of this question. So let's solve this numerical. So in this question they are given that 8-pole DC shunt generator which has a 778 wave connected armature connector. So wave connected means the number of parallel path is equal to 2. So therefore each parallel path will have 778 by 2 number of connectors. So therefore in this question they also given that DC shunt generator is going to rotate with a speed of 500 RPM. So this DC shunt generator we are going to rotate with a speed of 500 RPM. And also the load resistance means we are going to calculate load resistance of 12.5 ohm and the terminal voltage is 250 volt. So terminal voltage is 250 volt. So armature resistance is 0.244 ohm and also the field resistance is 250 ohm. So we have to find what is the armature resistance. So because of the generation of the power, it is going to supply the current. So this is the IA. So this load is going to consume a current of IL and this is the field current IF. So we have to find what is the value of the IA. So if you apply the KCL at this particular junction, the incoming current is IA and the outgoing currents are IF and IL. So therefore by using the KCL, the sum of incoming currents is equal to sum of outgoing currents. So IA is equal to IF plus IL. So therefore IA is equal to IF plus IL. So IF, I want to know what is the value of IF. The terminal voltage across this field resistance is VT. So because these two are connected in parallel, so same voltage. So Vt by Rf, and the load current IL is equal to voltage by resistance. Voltage across this resistance is Vt and resistance is RL. So therefore Vt by RL. So we know each and every value. So blindly substitute all those values. So Vt is equal to 250 and Rf is 250 ohm. And also your Vt is 250 and RL is 12.5. So we have substituted everything. So 250 by 250, which is 1, and 250 by 12.5, which is 20. So if you do the addition, finally we are going to get Ia is equal to 21 ampere. So therefore the current supplied by this DC generator, the armature current is 21 ampere, is the correct solution of this question. So by this lecture we have successfully completed the 40 questions of the ESE 2021 of electrical solutions in a very detailed manner. And if you like the content of our channel, then please do like, share and subscribe our YouTube channel, and don't forget to press the bell icon button, so whenever you upload a new video, the direct notification comes to mobile. If any improvements needed in our lectures, then please do come in the comment section. We will definitely include all those improvements in the coming lectures. Thank you so much for watching this lecture. Keep smiling, take care, and bye bye.